Hi, I hope everyone's doing good. We are going to do a little bit of conics review. So write it in standard form, find the focus, vertex, directrix, LR. One thing I want to practice is looking at the equation and knowing what type of conic it's going to be. We love doing that on multiple choice tests, just being able to look at it and name the conic. What you should be looking at is the squared. There's only one squared in this problem. That should be the easiest one to figure out. If there's only one thing squared, one variable squared, then we know it's a parabola. So this is a parabola. We should be practicing that as we go. Okay, so putting it in standard form, you want to keep the squared variable on the left and move everything else to the right-hand side. And we need that squared variable to start with a single positive 1. So here's what I want you to do. Make this side be a single positive 1x squared, ... Move everything else to the other side and do what you need to make that happen. Pause your video. Okay, so we moved the 8y, minused it to the other side. We moved the 5, added it to the other side. And then you needed to factor the negative 5 out of both terms on the left. So the negative 5 gets moved to the front, which gives me x squared plus 2x. I added a square. Now technically, because of distribution, I just added negative 5 squared to that side. So I need to add negative 5 squares to the other side to keep the equation balanced. See if you can complete the square and get this equation simplified a little further. Pause the video. Okay, so remember, for completing the square, it's half the middle term. So when I divide by 2, I get plus 1. 1 squared happens to still be 1. Combine like terms on that side. The negative 8y is not changing. 5 plus negative 5 happens to go away, so it's just going to equal negative 8y. Then remember, in order for it to be in standard form, your x squared needs to be all by itself. You need all the coefficients on the other side. So to move that negative 5 to the other side, you're going to divide by negative 5. So in standard form, x plus 1 squared equals negative over a negative 8/5 y. Okay, let's get some answer blanks set up. You should be able to tell me the vertex. Right now, you should be able to tell me the vertex. We're also going to find the focus, the directrix, and the length of the LR. We're also going to sketch it. See if you can answer vertex on your own. Hopefully for vertex, you know from x, it's in parentheses, you do opposite, negative 1. There's nothing over here at the y. Nothing is 0. The vertex is at negative 1, 0. This line is weird here. Then, to find the other things, we're going to need to use our 4p equation. 8 over 5 is equal to 4p. So to get p, we divide by 4. When it's already a fraction, those two just get multiplied together. So this is 8 over 20. Oops, not 4p. Equals p, which reduces... p is equal to 2/5. So, what do we know about our parabola? Let's set up some axes. We know the vertex is at negative 1, 0. Negative 1, 0. We know it's x squared. So x squared is a parabola that goes up and down. Those are the ones you've seen since integrated 1. So x squared goes up and down. It's positive. The 4p is positive, so it is going to go up. It's going to open up. And then my p tells me how far below and above the vertex everything is. So 2/5 below, this isn't going to be perfect, but 2/5 below would be the directrix, because I just said my parabola is opening up. 2/5 above would be my focus. So we need to be able to get those answers in our answer blanks. Luckily, the negative 1 isn't changing, right? My dots, my focus is still at negative 1, and 2/5 above 0 happens to be 2/5. My directrix is a horizontal line, so that's y equals 2/5 below 0 happens to be negative 2/5. And the length of my LR is the 4p. Remember, lengths of something, the LR is always a positive number, so 8/5. So I'd go approximately 8/5 to the right and approximately 8/5 to the left, and that would be my parabola. If we're going to make you graph it, it should come out a little nicer than that, but you get the idea. The answer blanks are where most of your points come from. So hopefully you are good with that one, and we'll try the next one. Okay, copy down number 2. Pause the video whenever you need to. Basically the same directions, but I want to practice figuring out what type of a conic this is ahead of time. I see x squared. I see y squared. So it's not a parabola because there's two things squared. Now I need to look at the numbers in front of those. Positive 2 and positive 5. Clearly they're different numbers and they're both positive. So this is an ellipse. Different coefficients. Both of them are positive. So this is an ellipse. See if you can start this one on your own, or you can just watch the video as I go. I need to get the x's together. I'll do extra steps for you guys. Get the x's together, get the y's together. Move the constant to the other side. Okay, now this needs to be a single positive x squared, so do some factoring. This one needs to be a single positive y squared, so do some factoring. See if you can get it all set up. Okay, here it is all set up. I factored the 2 out of every term that had an x. Then I added a square, so technically I added 2 squares to the left. That's why I have 2 squares added to the right. I factored the 5 out of the y's. I added a different shape because it represents a different number. So 5 triangles on the right, left, also 5 triangles on the right. See if you can complete the square and get this one in graphing form. Okay, here's my answer so far, just after completing the square. But you cannot have coefficients on the x squared parenthesis or the y squared parentheses, and you need it to equal 1. We already said this is an ellipse. Ellipse equations need to equal 1, so you need to divide each piece by 50. So 2 goes into 50 25 times. Y goes into 50, or 5 goes into 50 10 times, and now it equals 1 like it's supposed to. See what answers you can come up with. You should be able to tell me the center. We're gonna need to answer vertices. And we're gonna need to find the foci. So center, opposite of parentheses, opposite of the x parentheses, -1, opposite of the y parentheses, coincidentally also happens to be -1. Might be easier to sketch this one first, although the numbers aren't going to come out perfect. We try to make sure the numbers come out better for you on test day. Vertex, -1, -1. Left, right, 5, because the square root of 25 is 5. Up, down, a little more than 3, right? Because the square root of 10 is a little more than 3. Because square root of 9 is 3. Try to make it look like an ellipse. Some of these you can see real easily. Well, first of all, which ones are the vertices? Because it's not all 4 of them. Remember, for ellipse, the vertices are on your major axis. So the longer one, those 2 dots are my vertices, which happen to be the ones that came out to be whole numbers. So just use your graph paper. -6, -1, and 4, -1. So that worked out nicely. Foci, we need to use our c squared equation. Remember, ellipse has a plus in the middle, so that means your c squared equation has a minus in the middle. So c squared is equal to big minus little. C squared equals 15. C is the square root of 15. Also remember your foci are also on that major axis. So from the center, square root of 15, it's almost 4, right? Because the square root of 16 is 4. So 1, 2, 3, 4, almost. 1, 2, 3, 4, almost. The y value is not changing for those, only the x value is. So from center, you do plus or minus root 15, and the y value stayed the same. Hopefully this one was okay, and we're ready to move on to the next one. Okay, copy down number 3. Look it over and figure out what type of a conic it is. I see 2 things squared, 2 variables squared. one coefficient is -1, the other coefficient is +7. One of them's negative, that makes it a hyperbola. See if you can get it ready to complete the square. Group your x's and group your y's, but let's look at this. The x is negative. We like our hyperbola equations to have the negative in the middle. So let's group it with the y's first. Move the 37. Okay, now see if you can complete the square. See how far you can get. Okay, first of all, did you remember to factor the negative out of the x's? Is this what you're completing the square looked like before you continued on? If so, keep going. But here's the most common mistake. Negative factored out and negative times your triangle on that side. See if you can keep going. Here's what I got when I completed the square. Hyperbolas need to equal 1, so you will divide everybody by 140. So, y plus 4 squared. 7 goes into 140 20 times. Minus in the middle because it's a hyperbola. X minus 3 squared. 1 goes into 140. It doesn't, well, it just stays 140. Equals 1. This should be the final equation in standard form. You should now be able to tell me the center. And then we'll figure out the vertices, the foci, and the asymptotes. So center, opposite of the parentheses that has the x variable, 3, then the y variable, -4. So this is going to have a vertex at 3, -4. Then it starts like an ellipse, right? Square root of 20. What is that? A little more than 4? 1, 2, 3, 4, and a little more. 1, 2, 3, 4. Oops, I'm not doing that right, am I? It's under the y variable. Square root of 20 is under the y variable. I also probably should have looked at these numbers first. 140 is really big, so let's pretend that this is not to scale. I'm going to move this dot, because I cannot do this to scale on my paper. So let's say 3, -4 is like here. So I go up, down, square root of 20, which is approximately 4. A little more than 4, but I'm kind of scaling this by 2s. We wouldn't make you graph something this big on test day. And again, the numbers would work out nicer on test day. Oops. Just happened. There we go. Sorry. Then the square root of 140 is almost 12, so 2, 4, 6, 8, 10. I don't know. I'm just going to put it here because this is not to scale. Now, what we need to figure out is which ones are the vertices. So, looking at your equation, which way is this one going to go? So we would make the rectangle out of these points, and we would draw the asymptotes going straight through the middle and opposite corners. But what way is the hyperbola going to open? Is it going to go up, down, or left, right? So the minus is in the middle, which is where I like it. Since the minus is in the middle, I look at the front variable. The front variable is y, so it is going to open along the y-axis, up, down. So I can sketch it in. This is already not a very good sketch because it is not to scale, but you get the idea. So my question is now, what are those red dots? Because those red dots are the vertices. So it was from center. The center, well, the x value there is 3 because the center x value is 3. And then we went up and down the square root of 20. So -4 plus or minus the square root of 20. Plus for going up, minus for going down. Okay, foci, c squared equation. Hyperbola has a big minus in the middle, so your c squared equation is going to have a plus in the middle. It's opposite. So c squared is going to equal 140 plus 20. C squared equals 160. C is going to equal the square root of 160. The foci land approximately here and here, inside the cups of your hyperbola. So it is also 3 comma negative 4 plus or minus, but now we know it's plus or minus root 160. Finally, the asymptotes. You grab the you grab the y. Y plus 4 equals plus or minus, and then you grab your x minus 3. It's slope, rise over run. We went up, down, root 20, and we went left at right, root 140. This is the messiest thing you could ever possibly see. The numbers should work out much better on test day. Okay, number 4, let's go backwards. Copy down number 4, and then I highly recommend making a sketch of what's happening. That's how I solve them. It's how I recommend you solve them. So I'm going to set up a little set of axes. Let's see, 5, negative 3. I should have enough space to do this. Well, you get the idea. I can't quite hit the line, but so x equals 5. 1, 2, 3, 4, 5. X equals is a vertical line. Focus, negative 3, negative 3. 1, 2, 3, 1, 2, 3. This is what the problem tells me. Also, this doesn't need to be to scale because this is just my work. By telling me the focus and the directrix, now I know my parabola is doing this, right? The focus has to be inside the parabola. So the vertex is right in the middle. So if you count this length, this is why we do it on graph paper. If you count that, you should be able to find the middle. Or you can add and divide by 2. That's how you find the middle mathematically. So 1, 2, 3, 4, 5, 6, 7, 8. So 4 away. 1, 2, 3, 4 away from both is the vertex. So this is the point 1, negative 3. So let's set up the equation of a parabola, right? If we know the parabola is doing this, what do you know about which variable is squared? So it's opening sideways. Sideways parabolas, the y is squared. The x is not. You know the vertex, so put it in the correct parentheses correctly. The y is going to make it plus 3, and the x is going to make it minus 1. Then we just need to know this distance from focus to vertex, which is also this distance. It doesn't matter which one you wanted to use. But I can clearly see that distance is 4. So 16, right? P equals 4. Let me write this out for you. So I need 4P, which is 16. Then when you get that number, it will always be positive. Nothing about what you've done is ever going to make that a negative number until you look at the question. If my parabola opens left, the x values left are negative. So I need to write my own negative sign right there. And that's the most common mistake. People forget to check and see if it should be negative. And that's our answer. Okay, let's try another one. See if you can set up some axes. This one, it goes all the way down to negative 13. Probably don't do these to scale, but set up the dots and label the dots so we know what's happening. Okay, so here's what I'm talking about. The graph paper has nothing to do with this problem. This is not to scale. But they give me the vertices and the foci. I should now be able to find the middle. You can choose vertices or foci. The middle of either one is going to give me the center of my ellipse. So since it's not on graph paper, or I'm not using the graph paper, this is where you want to add and divide by 2. 3 plus negative 9 is negative 6. Divided by 2 gives me negative 3. Sorry, clearly it was 2, right? And then the middle is negative 3. So the center is 2, negative 3. Let's set up a generic equation of an ellipse. Don't forget the equals 1. Most common mistake is forgetting the equals 1. You know the center now. Plug it in carefully and correctly. And then you can see how far away the vertices are. Or if you can't see it, you can do the math and count it, right? From negative 3 up to 7 is 10 away. So when I was drawing my ellipse, I went 10 up and 10 down from center. What makes you go 10 up and 10 down? Well, under the y is up, down. and the square root of 100 is 10. Then we can see or count our C value for our distance between center and focus. From -3 to 3 is 6. So C is 6. So my C squared equation, remember there's a plus in the middle, so my C squared equation has a minus. I know that C is 6, so 6 squared, right? 36 equals. I already know the 100 is A squared over here, right? That's A squared minus B squared. Subtract it over. B squared equals 64. B equals 8 if you find that useful, but remember it's B squared that goes in your equation. This is the equation of my ellipse. Okay, one more. See how far you can get with this one. Plot the points, whether you choose to use actual graph paper or not. Work on finding the center, set up your equation, and see how far you can get. Pause your video. Okay, here's just a little bit of what I've done so far. Set up my generic equation. It said it's an ellipse in the problem. Don't forget equals 1. So between -6 and 4 is -1, and then clearly the y value is the same. It's the same in every single thing given. So put that into the equation, x plus 1, y plus 2. Then I can see how far left-right I went from center. I went left-right 5. So if I'm going to go left-right 5, this must be 25, right? The square root of that number tells you how many left-right you're going to go. Then I did not put it in the picture because it's a mess, right? But I can tell they gave me C. -1 is the center, and they went plus 2 root 3. So the foci is 2 root 3 away, which means C equals 2 root 3. So C squared equals A squared minus B squared still. Always a good idea to use parentheses when you're squaring something like 2 root 3. A squared is the 25. Remember, that's already squared. So remember, when you square something like this, 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. Do a little subtraction. B squared equals 13. We could square root that if you want to, but remember, it's that whole number that gets written under your variable. This is our equation of the ellipse. Let's see what's next. Circle. Okay. Copy down the problem, see what you can do with it. So generic equation of a circle. They give you the center, so plug it in. And then they give you another point. So I know an x value and a y value, and I can solve for r, or r squared. So x is 6. Coincidentally, it says plus 6. Y is -2. And I'm trying to find what r squared equals. That's 12, and then squared is 144. That's 5, and then squared is 25. Add them together, and r squared equals 169. So, x plus 6 squared plus y plus 7 squared equals 169. I only square root that if I'm sketching it, right? The radius would be 13, but it equals that for my equation. There's the equation of your circle. Last slide, I just want you guys to name these conics. Pause your video and see if you can get the name of all 4 of these conics right. When you unpause it, my answers are just going to be on the screen, so pause it and try it on your own. Okay, there you go. Hopefully you noticed 2 different coefficients with the squares, but they're both positive, ellipse. 2 different coefficients squared, but more importantly, one of them's negative, hyperbola. Exact same coefficients on the squares gives you a circle, and only one thing squared gives you a parabola. So I hope this review of conics helps you guys out. Have a good day.